Assalamualaikum and a very good morning to everyone. So today I want to show you how I mark first Monday test for my student. So this is Form 5 paper. Okay, so question number 1. So diagram 1.1 shows a trace of sound wave on a CRO, cathode ray oscilloscope screen, when a guitar string is plugged with a certain displacement. Okay, so the first question, what type of wave is sound wave? So the answer is longitudinal wave. And then on diagram 1.1, this diagram, sketch a new trace to show another sound wave of the same pitch and louder. Okay, so remember pitch will relate to frequency. And then loudness, okay, will relate to the amplitude. Same pitch, so the frequency should be the same. Okay, so it means that this part should be the same. Okay, same frequency. Loudness, louder, so bigger amplitude. Okay, so this is perfect answer. The first tick will be for the loudness. Okay, bigger amplitude. Second tick will be for the frequency, same frequency. The second question. Okay, so the string of a guitar in diagram 1.1 is plugged with a frequency of 1 kilohertz. Okay, K here means kilohertz. The speed of sound produced is 330 meter per second. So calculate the wavelength of the sound wave produced. Okay, so to answer this question, so it's better to write the formula first. So V equals to F lambda, then substitute accordingly. So V is 330 like that. F is 1000 hertz and then lambda. So you calculate. So the first tick will be for this substitute value. Okay, one tick. And then the final answer. Diagram 1.1 shows top view of a square room. So this is top view of the square room. So the sound produced by the guitar passing through an open door and window. So this is the door, open door, and then open window. So on this diagram, diagram 1.2, draw patterns of wave after passing through the door and the window. Here is the wavelength lambda. Alright. And then look at the size of the opening. This is the gap, size of the gap. So you can see that size of the gap, okay, through the window is smaller compared to the gap through the door. So when the wave travels through a smaller gap, it will be diffracted. Diffracted, more obvious, more diffracted. So it will form semicircular pattern wave like this. Okay. So just draw semicircular pattern wave. At least you have 3 wavelengths. Okay. Then if let's say the gap is bigger, so the diffraction will be less obvious. So less obvious will be represented by straight diffracted wave with curve at edges. Okay. Then you better draw the direction, always 90 degree to the wave front. Okay, like that. Okay, like that. So and try to make sure that the lambda is the same as the incident lambda. So it means that the wavelength here and here should be the same. Okay, so this is a perfect answer. Okay, good. Alright, I show you some of other answer. Right, look at this. Okay, so diagram 1.1, okay, still the same question just now. So same frequency, okay, good. And then bigger amplitude. So the first mark correct, second mark correct. Okay, and then longitudinal wave also correct. So look at the calculation. Alright, so using this formula, then substitute V, okay, good. And then frequency, okay, 1 kilohertz written like that, it's okay. So means that 1 mark here, and then you calculate correct unit. Okay, mark 2. Then next one. Okay, so since the mark here is only one mark, so I will just look at the pattern. So as long as your pattern is correct, so you will get 1 mark here, 1 mark here. Okay, so but it's better to make sure that the lambda is the same. Okay, alright, next one. Look at other answer. Alright, like this. Okay, so this student misunderstood the question. So instead of drawing in the diagram, this student draw outside the diagram. So if like this, you cannot get the mark. Okay, so here will be cross 1, cross 2. Alright, so this one should be okay. Okay, this is mark 1. Okay, here, can give mark or not? In this case, we don't give mark because this student forgot to write the unit. Okay, so no unit, there will be no mark. Okay, and then here, same just now. So I look at the pattern, this is correct. And then here, this is not correct, okay, because it should be spreading like that. Okay, so it should be like this. Like that. It should not be converging, okay, it should be diverging. Okay, so with this, we don't give mark 2. Okay, so this student give the type of wave is transverse. Okay, transverse is not correct. Example for transverse wave, you can write, if let's say the question asks about water wave, okay, or maybe light wave, then the answer will be transverse wave. Okay, but for sound wave, remember it should be longitudinal wave. Okay, so this diagram, okay, can see here the frequency already changes from here to here, so it means that this is already bigger period. So the period, okay, like this, right? This is one period, should be according to the original wave. This is one period, but now, okay, the answer that given by this student, the period already become longer until here, so means that frequency is not the same. Okay, not the same, so that's why no mark for the frequency. What about the amplitude? So amplitude look like the same amplitude. Okay, so here amplitude also no mark. So as for this student answer, he actually write for same loudness but smaller pitch. Question number 2. Diagram 2.1 and 2.2 shows circuit used to investigate the relationship between resistance and cross-sectional area of a wire. So they are using wire SWG36 and the SWG24. Same length. Okay, so the length is the same, but the type of wire, the thickness of the wire are not the same. And then you look at these two diagrams. So the ammeter reading, okay, compare. So they have same ammeter reading. Thickness, so this is thinner, this is thicker. And then the voltmeter reading, look at the pointer. So we know that this is the first diagram, 2.1 has bigger voltmeter reading. Second one has smaller voltmeter reading. Okay, the first question. What is the meaning potential difference? So potential difference is work done when 1 coulomb of charge move between 2 points in an electric field. So we define potential difference by work done to move 1 coulomb of charge from one point to another point in an electric field. Okay, so this one can be considered is the correct answer. Okay, so using diagram 2.1 and diagram 2.2, this is the normal format for paper 2 question. They love to ask you first to compare. Alright, see, compare. Then after compare, here see, compare. Then after that you relate. Okay, so when the question asks you to compare, you need to look at the diagram and just refer to which diagram, refer to the diagram like this. Compare the cross-sectional area of constantan wire. Cross-sectional area. So just write, see here, this is thinner, this is thicker. Cross-sectional area of the constantan wire in 2.1 is smaller. Okay, correct. Okay, then 2.2. And then potential difference, look at the reading. So 2.1 is small, 2.1, yeah, higher, greater. Okay, and then magnitude of current, look at the reading. Okay, same reading, so the magnitude is the same. Compare the resistance. Okay, of course, thinner, which is the first diagram, thinner will have bigger resistance. Okay, so resistance 2.1 is higher. Then after that, you need to relate cross-sectional area and resistance. So now you know that when the cross-sectional area is bigger, so the resistance will be smaller. Right? Like that. Smaller cross-sectional area, bigger resistance. So what will happen to the reading of the voltmeter when another constantan wire, SWG36, same length, connected parallel to the wire in 2.1. Okay, here. So we have another one connect here. So when we connect another one here, the the total resistance, the effective resistance of the circuit will drop. This voltmeter is taking the potential difference in between these 2 points. Since the effective resistance here drops, so the voltmeter reading also will drop. So the answer should be the reading of the voltmeter will decrease due to the total resistance decrease. Okay, without this word total, so there will be no mark 2. Okay, so this is the mark 1. Reading of the voltmeter will decrease, correct? And then total resistance decrease. Another word that you can use will be effective resistance. Effective resistance decrease. We need to use the word total or effective resistance because it refers to the whole system resistance. Okay, look at this answer. The meaning of potential difference defined as work done for moving 1 coulomb of charge at 2 points is actually from one point to another point in an electric field or in an electric circuit. So that's why I put ... here. So not a complete answer, but still can be given mark. Alright, so compare the cross-sectional area. So you can also use this symbol. Okay, diagram 2.1 is smaller because the question focusing on cross-sectional area. So if you write diagram 2.1 is smaller, okay, so it means that the cross-sectional area for the wire in diagram 2.1 is smaller, so accept. Okay, and then here 2.1 is bigger, potential difference bigger, and then the magnitude of the current for both will be equal. Okay, so here you can use the word equal, you can use the word the same, okay, but please don't use the word constant. If you write diagram 2.1 and diagram 2.2 is constant, the word constant doesn't mean they are equal. Okay, so be specific. Just use the word equal. Okay, correct. Or you can use the word the same. This is correct. So please don't use the word constant. So here also can use the same thing. So the resistance 2.1 is bigger compared to 2.2. Then relate. Okay, so when we use the word relate here, when you answer the question for relate, don't use symbol. You write as if you are writing a hypothesis. So use this keyword, cross-sectional area, and then resistance. Okay, so the smaller the cross-sectional area of the constantan wire, the higher the resistance of the wire. Many students misunderstood this. So the reading of the voltmeter will be the same. No, because why? We already add in one more wire to the circuit, which is parallel. Okay, so the voltmeter reading will drop, okay, due to the effective resistance is smaller. Section B. Okay, question number 1. So 4 classrooms in your school are combined and renovated to become an auditorium. So the table below shows 4 designs for the renovation of the auditorium. So they have design P, Q, R, S, and then the characteristic, shape of the ceiling, material used, distance between 2 loudspeakers, position of the loudspeaker. So here they have for the ceiling, so they have flat, concave, and convex ceiling. And the material they have only 2, which is the hardwood and also the softboard. Then the distance between 2 loudspeakers also have 2, so you need to choose between large and small. And in position of the loudspeaker also have 2, low or high position. So you are required to determine the most suitable design that can produce better sound quality. Study the specification for 4 designs based on the aspect given in table below. Explain the suitability of the aspect. To answer this question, it's better to write in table form. As for my student in UB1, Ujian Bulanan 1, I provide them with a table to make it easy for them to answer. I prefer students to write in 3 columns. So for the aspect, shape, material used, distance between 2 loudspeakers, position of the loudspeaker, better to write in the first column. Right, so aspect here. So just copy shape of the ceiling here, copy here. And the material used, you copy here. And then distance between 2 loudspeaker and the position of the loudspeaker, okay, you copy like that. Okay, then you make 3 columns like that. Shape of the ceiling, so it should be concave shape. The wave is actually will be focus. This is the keyword. Will be reflected, converging to the focal point. This is good. Hence the sound, okay, will be clearer. The shape of the ceiling. Okay, so sound wave, let's say here will go to the ceiling and it will be focus. Go to the ceiling will be converging to a point. So here, so it means that you need to use this word focus or converge to one point. Okay, the material used should be softboard, soft material, absorb the sound wave, okay, correct, or reduce the echo produced. Absorb sound wave or reduce echo produced. The distance between two loudspeakers should be large. This is correct. This is actually relate to the interference. So when the distance between two loudspeakers, I draw here. So let's say this is your loudspeaker. So the distance between two loudspeakers is actually A. The wave produce having interference, okay, interference. So if let's say A is bigger, from this formula lambda equal to X over D. So when A is bigger, X will be smaller. What is X? X will be the distance between two antinodal lines, which actually will represent the distance between two antinodes. What is antinode? Antinode will be the point which is having constructive interference. Okay, so antinode is the point that is having constructive interference. So if let's say when the distance between two antinodal line decreases, there will be more antinodal line produced. So it means that there will be more antinodes produced. So it means that the auditorium can occupy more seat, more chair, they can hear loud sound. To reduce the distance between antinodes, okay, this is correct. I can give mark here. Reduce distance between antinodal lines, reduce distance between antinodes, hence more antinodes produced. And then the point that is having antinodes is where the sound will be louder. To say clearer, it should be louder sound. Okay, but here I already give mark for this. The position of the loudspeaker, yes, it should be higher lah. Okay, so the higher position, there will be less obstacle. Alright, so this is the keyword. Remember that, less obstacle. Which one is our choice? Shilling, concave, softboard, large distance between two loudspeaker, and then high position. So no doubt it will be Q. Alright, Q. So this is mark number 9. Here just now is mark number 1, 2, 3, 4, mark 5, mark 6, mark 7, mark 8. Mark 9 and mark 10, you just copy Q, just copy this. The shape of the ceiling is concave, softboard material is used, the distance between two loudspeakers is large, the position of the loudspeaker is high. It will be mark number 10. So here I just look at the keyword. Shape of the ceiling, concave, material, soft, distance, large, and then position high. That is enough for mark number 10. So this student get 10 marks. Good. Still focusing on the same question. Material used, okay, we know that it should be softboard. And then look at this answer. It should be absorb sound wave. Means that absorb incident sound wave, not absorb reflected sound wave, because once the wave already reflected, it will go towards the opposite side. So it means that it cannot absorb, the softboard cannot absorb the reflected sound wave. Okay, so that's why this is wrong. If you want to use the word absorb, need to be absorb the incident sound wave. This student also write reduce echo. Yeah, echo here is actually the reflected sound wave. Alright, so in this case I give mark, okay, but I put BOD mark, okay, but it's better next time don't write this. If you still want to write absorb, better write absorb sound wave or absorb incident sound wave. In that case, the echo will be reduced. So distance between two loudspeaker is actually A. Okay, if you refer to this formula, lambda equal to AX over D. So this is the interference formula. So lambda is the wavelength. A is the distance between two coherent sources. X will be the distance between two consecutive antinodal line. And then D is the distance between source, the coherent source, and where you observe the interference pattern. Okay, so when A is bigger, X will be smaller. So we actually fix the wavelength and also the distance between the coherent source and where the interference pattern is observed. Okay, so when x is smaller, okay, look at this answer. Just now we know that when x is smaller, so means that more antinodes produced. Okay, but this student write another sentence, bigger distance of x. So when this happen, this answer is actually contradict. At first saying that the antinodes will be more, but then bigger x. Okay, so that's why here, when it contradict like this, I don't give mark. It's better to really understand what you write. Okay, to prevent you from writing contradict answer like this. Okay, essay question number 2. You are asked to investigate the designs and the characteristic of 5 filament lamp shown below in this table. So explain the suitability of each characteristic of the lamp and determine the lamp which can produce brightest light. Obvious, there are 4 characteristics here. So one is the type of wire, either tungsten or copper. And then the thickness of the wire is either thin or thick wire. And then the shape of the wire, it's either coil or not coil wire. And then the pressure, the nitrogen gas pressure is either low or high pressure. Okay, so again, it's better to write your answer in table form like this. Okay, so this time I prepare the table for my student. Okay, so you have three column. So the first one is the aspect. Okay, then characteristic, explanation. Alright, so type of wire. In this case, it should be between copper and tungsten. So you look at the application. Now, the wire is used as the filament of a lamp. Filament lamp, to produce more light, it need to produce more heat. To produce more heat, then the resistance of the wire should be higher. Okay, so here you can see more light. More light means that more light energy. More light energy. In order to produce more light energy, so you need to have more heat energy. Okay, in order to have more heat energy, so the resistance of the conductor should be higher. Okay, now you must know what are the factors affecting resistance. So if let's say you want to have bigger resistance, okay, so the factor will be the length of the conductor, the cross-sectional area of the conductor. Another one will be the type of the conductor. Okay, type of the conductor. So here you have copper and also tungsten. Alright, so your choice will be tungsten because tungsten has more resistance compared to copper. Copper normally used in the transmission wire, okay, due to the smaller resistance. Okay, but in this case we need to have more resistance because you want to create more, you want to have more heat energy, okay, in order to have more light energy. Hence, the bulb will shine, will be brighter. Right. As for the cross-sectional area, so in order to have more resistance, so the cross-sectional area should be thinner or smaller cross-sectional area. Okay, and then the length should be longer. So these are the 3 factors. Okay. Now we need to look at these 3. Okay. Okay, so type of wire, yes, it should be filament wire. Reason, it has high resistance. So here is mark 1, okay, tungsten. Mark 2, higher resistance. And then the shape of the wire should be coil. So this is mark 3, okay. Coil wire is longer, it's good, okay, correct. But then, okay, see, it has increased efficiency of it. So what do you mean by increased efficiency? So here actually we really need to see what is the relationship between longer and the resistance. So it's better to write the way you write hypothesis to explain. The longer the wire, the bigger the resistance. Okay, please don't write symbol like this. I am using shortcut. So you need to write in full sentence. The longer the conductor, the bigger the resistance. In this case, I don't give mark because not enough. Thickness of the wire should be thin, yes, thinner wire. So this is mark number 5. The resistance of thin wire is high. So this is the same as you write the thinner the wire, the greater the resistance. Okay, mark 6. And then the nitrogen gas should be at low pressure. This is correct. This is mark 7. The wire in low pressure of nitrogen gas get burned. No. So the pressure here is actually related to pressure law. When the temperature is smaller, the pressure is smaller. But when you use the light bulb, after some time, the temperature will be very high. So when the temperature is high, according to pressure law, pressure also will be high. So it means that pressure of the gas, because gas law, pressure law is a gas law. When the temperature of the gas in the bulb is higher, so pressure of the gas in the bulb also will higher. So it means that the bulb can break easily. Okay, so that is the reason. Okay, so in this case we don't give mark. So it should be when the temperature of the gas is higher, after you use the bulb for some time, pressure of the gas will be higher. So you can use the word break, the bulb can break, or you can also write burst also, but not really, but can use lah. Alright, so I prefer student to use the word break. As for your choice, okay, we need to look at tungsten, coil, thin wire, and also smaller pressure of gas. Here lah. You can see tungsten wire, thin coil, and then low pressure. So your answer should be R. Then, so what is your choice? This is mark 9. Wire made up of tungsten, coil, thin, nitrogen gas at low pressure. This is mark 10. So this student get how many marks? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 marks. Okay, well done. The same question, okay, but this student misunderstood. Instead of focusing on higher resistance, he focused on smaller resistance. Okay, so when you choose wrong application, okay, then it will affect your mark. Okay, just like this. See, type of wire, copper. So copper is wrong. Okay, see the reason? See, low resistance. So this is wrong also. Coil shape is correct, 3, okay, but the coil shape actually does not reduce the resistance, it increases the resistance. Okay, this is mark 4. And then thickness of the wire should be thinner, kan? And then bigger cross-sectional area, the smaller the resistance, also wrong. Okay, 6. Alright, so but the way he write the answer is a good way of writing, because this is just like you are writing a hypothesis. But then since he choose wrong characteristic, so cannot give mark here. Alright, then low gas pressure, this is correct. This is mark number 7. Low pressure, lower kinetic energy, hence less heat produced, resistance lower. No, okay, no, this need to be related to pressure law. And then the choice lamp Q, wrong, so mark 9. And then confirm your 10 also cannot be given mark. Alright, so here only 1, 2 mark. Okay, alright, but it's okay to make mistake. Okay, next time need to be more careful. Alright, so next time hopefully he will get a better marks. Okay, keep trying.